How's going on, everybody? Welcome to one long video of creating chatbot from scratch, and till the end of this video, which is less than an hour, you are going to able to create this. Okay, so if we ask hi, it responds hi, hello, it responds hello. If we say bye, it says bye. What is your name? It says I don't know. Okay, it is silly answer. And I want some food. It says you are not out. You are going to see what this out mean. And there are a lot of scopes to make this chatbot better, but there are some limitations. And first limitation is obviously a lot of RAM usage. So you are going to see we are only going to use really less chunk of data, but that is the topic for a later part in this video. And we just trained for around 35 epochs, and it already reached pretty good point of predicting the things. We haven't hard coded anything. It is just predicting on its own. And this is what we are going to create, a sequence to sequence chatbot using keras library. If you are excited enough to start creating chatbot, you may proceed further. Plus we are going to talk about a dataset in a bit. Plus if you want whole code, will be in down description with this GitHub link. Obviously this link will be in down description. And separately I have created this series of videos, and I thought why not just combine these all videos in single video. Plus, if you haven't subscribed to my channel, make sure you subscribe to this channel, and we have completed 2000 subscribers. I just can't thank you enough. So I'm just so glad that I have really good audience such you. And that's it. Let's start the series of videos. And for the data, we'll be using Cornell movie dataset. If you want to download this, I will link it down description. Go ahead to this website and download the zip file. After you download the zip file, you will get some files, but from those files we need just two files. One is movie conversation and movie txt. Let me quickly show you how these files looks like. This is movie lines.txt, and I would suggest you to give this dataset a time to read it and to know how you can pre-process this dataset. Quickly, let me explain you. Over here we have the ID of the conversation, then user, then movie, then the name of the user, and this is the dialogue itself. And this file contains the whole conversation between the this ID which I have shown you. So these are the conversations. So basically we have a total of so many conversations. I think we have total of 83,097 conversations, full conversation between the users, and you can give more time to understand this dataset. Alright, so let's quickly jump to the spider, and make sure you have the Python file and the data file in the same directory. If not, you have to give the full path which I'm going to define in a second. So for now we are not going to import any library. So what we are going to do is to open the files first of all. So I'll be using spider because it is quite easy to access the variables from this variable explorer tab. So these are my files in the corpus folder. Let's first open the movie lines. Let us name it as lines, and we'll be saying open. We'll be using open, which is inbuilt. You do not need to install this module separately. So I'll be saying open inside the corpus folder, which is movie lines.txt. Open this, and encoding for this is UTF-8. Then while opening this we might get some errors. What we want is to ignore those errors, so we have to specify right here make sure there is s after the error, so don't get confused or get a typo over there. So I'll be saying errors equals to ignore. Then after that we need to read this file. Alright, so after reading this file, what we need to do is to, let me quickly show you. Wait a minute. Alright, so this is the movie lines, right? And this is splitted after a new line. So in programming we know that /n represents new line. So what we have to do is to say dot split at every new line, so that we will get the list of, alright, so we'll get the list of every new line. Let me quickly run this line and show you how this looks like. Alright, so this is our variable and it will take some time as it is too much data. And zoom this up. So we will be having the conversations after every new line break, and this is list, right? And these are the dialogues. So now we have to do same thing to read the conversation file. My god, I will control plus Z and copy this and paste it, and I will name it as converse, and the name of the file is conversations, and run it. So we have two variables, conversations and lines. Now we have to pre-process this. So why we need to pre-process and what we need actually from this pre-process? Alright, so what we actually want is to, let me take you to first. Alright, so what we want is to list of this L194, L195, L196 and L197 and so on. So in our list, first list will be this, second list will be this. So we'll be having nested lists. How we can do that? We are going to iterate in this file and split it at this particular keyword. Then we will be grabbing the last value, and then from that we will just take these values and gonna replace these single quotes and commas, and then we will be splitting it at spaces, right? These spaces, so that we will be having a list of these, which is our task. Alright, so we will be saying for convert in converse. Alright, so we'll be saying, okay, so first of all let's create another variable which will store this list, and we will name it as XCHN, exchange. We will take it as a list. So we'll be saying for convert in converse, and we'll be saying EXCHN dot append. What to append is to convert dot split. Where to split I have already shown you. Plus 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 dollar plus plus plus. What we want to grab is the last value from this split list, and from that last value we need our these values. I have already explained you, please remind if you are getting confused right here. Then I have also told you that we need to replace single quote with nothing, and one more thing we need to replace. Let me zoom out this. One more thing we need to replace is this comma with nothing. Then at last we'll be saying dot split. Alright, so let's iterate and hope for we do not get any error. Let's run this up, and congratulations, it will take some time to open. Alright, so this is what we actually required to do, and we got the list of these conversations. Now we have to do same thing for these lines, but this time we'll be doing something different. What we want is to, let me quickly take you through it. These are our movie lines. What we want, we need to create a dictionary with the key this and the value of that key will be this. Why you need to do it? Because later we need to use that list and convert that to question and answer list. Alright, so let's quickly create a dictionary. We'll be naming this dictionary as dialogues. You can use any naming convention you want. So I'll be saying for line in lines, what do we want? We actually will be saying for dialogue, and for the key what we want is line dot split. And where to split? Okay, so we will be splitting at this again, and we'll be grabbing first position or first index or 0th index as the key of the dictionary, and the last index as the value of that key. Alright, so let's quickly do that. Alright, so we'll be saying line dot split. Where to split? At dollar. Alright, so split at this position to, okay, what is this? Alright, so we need to, alright, so we need first position as the key, and as the value what we need is to we'll directly pass it line dot split. Where to split? Split at plus 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 dollar plus 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 and give it a space, and what we need is the last value. This is quite easy compared to previous one. Let's run this, and we'll be having a dialog dictionary. It will take some time to load. Alright, so this is the dictionary, and that is what we want. As you might know that for training a sequence to sequence model, we need to convert our data to questions and answers, where question will be the input to our sequence or encoder. Encoder will output a context. We will talk about it later in detail. We need to convert them to question and answers. How we can do that? That is quite easy. First of all, I'll be creating a list for questions and a list for answers. For training we need to pass questions, and we will be expecting it to predict the answer, and we will calculate the loss based on original answer and the predicted answer. Alright, so for doing that, what we will be doing, and okay, we have our exchn. Okay, this is it. This is the list of conversations. So what we need to do is to iterate over this list, and then from that iterate in this particular list, then this particular list, then this particular list. And when we grab this particular value and this particular value, we will be using that dictionary to access the value by passing in this key, this key, this key, and so on. So we'll be saying for name it as convert, because we are not using this old variable, and I'll be saying for convert in exchn. And what we'll be doing, we'll be iterating through the list, and then we will be iterating in that convert list, because convert is also a list and exchange is list of list, nested list. So we'll be saying for I in range of length of convert, and now -1. Why -1? Give me some time to open this. Alright, so this is the list. As an example, think of this, that like these two are the question answer or conversation, one conversation. So what we need is this as question and this as answer, and if we take this as question, what will be the answer for this? We will have no more answer for this. So what we need is question will be length -1 and answer will be up to the length of it. I hope this makes sense to you. Make sure this whole code makes sense. So we'll be saying questions dot append what we need to append? We need to append the value from this diag. So we'll be saying diag, and this index position, meaning convert, in the convert that index position I as a question, and this is it. And for the answer, we answers dot append will be saying diag, and in that we need to pass convert, and index of convert will be I plus 1 because the answer will be next to it. Let's quickly run this code and let's see how it looks like. Alright, so these are our answers, these are our questions, and it will take some time to load. Alright, so these are our answers, these are our questions, and let's quickly see if any question makes sense. Let's grab this seventh one. Seventh one says why, and here says unsolved mystery. You may spend some time to look at them, but they are clearly question and answers. And now we will delete all other variables which we are no longer using. Why we are going to do that? Because when we using Kaggle to train this data set, then memory would be the greatest issue, because it requires a lot of memory when we run hot encoding output vectors. So we need to delete them all and lines. Let's run them up, and we will be having just question and answers. Alright, so in this video we are going to more pre-process our list of questions and list of answers. And first of all, let us first pre-process fixed length of questions. Now our question has a length of like 13, 15, 20, 30 or 1, 2, 3. Now that is not good for our training purpose. So what do we need to take a fixed length? Like if the length of question is greater than 13, we will exclude it. If the length is less than 13, then we will include it. So for that I will copy and paste code so that it won't take so long. I will explain you, don't worry about that. Alright, so I will name the new list as sorted question and sorted answers. Now what I am doing, I am iterating in the list of questions, or you can say I am iterating up to the length of questions, so that I may access the index of that particular value of that question list. Alright, now if we are checking if the length of the question at that particular index is less than 13, then we will append it to the question and append answer. Make sure here it says answer. We will append answer of that particular index and question of that particular index to their respective sorted answer and sorted question. Alright, now let us see running it and how it looks like. Awesome. Now here are our sorted answers and here are our sorted questions. Now you could see that first of all there will be length of 1, then there will be length of 2, then length of 3, length of 4, and so on. It is like that. Okay, now we have scaled out the value fixed length of the question. Now we have to remove the punctuation marks and convert all the capital letters to small letters. Now for that I will again copy a function and paste it over here. Now for this purpose we need to import a library or module called RE. Now we have to import RE, then RE stands for regular expression. We apply regular expressions to our strings, then we have our cleaned text. So what we are doing, we are saying if there is short form of IM, we will replace it with IM and so on. if it is what's, we will convert this to what is, and if there are punctuation marks, then we will replace them with nothing inside that particular text, and we will return the text. Now we have to iterate through the list of questions, sorted answers and sorted questions, and we have to apply this clean text to every word in those lists. Now let us see how we can do that. Alright, so here we go. Now we have our another list called clean question and clean answers. So what we are doing, we are iterating in the sorted questions and sorted answers. Then we are saying clean question, which is newly created list, dot append clean text, which is the name of this function, and we are saying and passing the line, which we are iterating using for loop. Let us run this and see how it performs. We got an error which is clean text. Oh, we didn't define function yet. Let us define the function. Now let us run these lines. Alright, so now we have our clean questions and clean answers. Let's have a look on it. So this is clean right now. There are no punctuation marks, all are in lowercase, and it is perfect to send into our model training. But before, we need to convert them to integers. As you could see that machine learning algorithms and deep learning algorithms require to work on integer data set rather than string format. So we need to convert them to index or integer values. So for this purpose, we used to create a vocabulary. Vocabulary means vocabulary is a dictionary where there is each and every word which is available in in clean answer and clean questions. Alright, so vocabulary contains every word available in this clean answer and clean question list, and a unique value assigned to that particular word. Alright, so but before, we need to do one more thing. Let me just first copy the code and paste it. Now we have to do one thing before that, which is this one. Alright, wait. In clean answers, you could see that we have a variable length of answers, whereas our questions have fixed length maximum up to 13, whereas it's not clear in answers. So we have to do that step. Now what we are going to do is to cut out first 11 words from the clean answer list. So we are doing same thing, iterating through clean answer and doing the same stuff. And if I run this, and you could see that now we have max length of 11 and less length of 1 word. So now let's proceed further creating a vocabulary. So let us first delete unused variables. Alright, so now we are only working with these two variables. Before making the vocabulary, we first split out or first take only fixed length of answers and questions. So we can do that by using simple slicing like this. Now we would have only 30,000 values of answers and 30,000 of questions. Now we will proceed further and creating a dictionary or vocabulary. But before, there would be some words which would have repeated just a single time or twice or 3 times. Some words will be which are most common, and some would be names which would be used only some amount of times. So we need to somehow take out those words, as we need faster computation in lower memory space. So we will be creating a dictionary of key as a word as a key, and value will be the count of that word. So we could do that by using this trick right here. So we are creating word to count dictionary, and we are iterating in clean questions and clean answers, and in that clean question we are splitting that particular index value into words, and then we are checking if the word is not in this dictionary. We will add that word to this dictionary and we will specify the value as 1, whereas if that word is already available we will increment the count. And we are doing same as clean answers, and we are appending to same dictionary. Let us run this and see how does that looks like. So as you could see, the length is 15,843. It is quite big for a cheap laptop or cheap computer, or even if it is too much if you run this on Kaggle server. So we need to remove the irrelevant words. So as you could see, it is just count as 2 and it is 32, and here it is tonic. Now there are some words which we don't even don't even use while talking to our chatbot, so we need them to filter out. So first of all we will specify the threshold value. So I'm saying if the word count is less than 5, remove that, and if it is greater than 5, take it. So I am creating a vocabulary and I am saying if the word has count greater than 5, store that in vocabulary and assign a unique value to that particular word, which I have already explained what is vocabulary. So I am iterating in the dictionary which we have just created, and in that I am checking if count is greater than threshold. Append that value to particular key in the vocabulary and increment the value of word num as we need to assign a unique value to it. Let us run and let us have a look how does it looks like. So here we have reduced the size of 3023 and previously it was 15,000. So you could see how fast it will be to train this on our Kaggle server or even on our laptop. So this is our dictionary where this word is a key and this is unique value assigned to them. Now let me explain you some more concepts. Let us get rid of this. And so think of like our answer is high. Now what we will not just directly feed in high to our decoder model. What we need to feed in a unique token which signifies start of string and a unique token which signifies end of string. So we have to do this for every question or every answer in the clean answer list. We have to append SOS and EOS token to them. We are not doing in case of answers because we will pass the question to the chatbot, whereas answer is something which will be predicted by our chatbot. So it is quite easy to do. We will iterate in the list of clean answer using the for loop, and we will be saying at that particular index and SOS plus that value and EOS. Let us run this and see how does it looks like. Alright, so here you can see SOS, the thing is Cameron, I am at mercy, and EOS. Alright, so it is perfect. Alright, now we have to append these tokens to our vocabulary because these are also a string, and as I have explained, deep learning do not expect string as input. So that is also quite easy to do. Actually, we will have tokens EOS and SOS. And what does it pad mean? I will explain it later, but for now pad means if the length of sentence is 1, we will add padded words to it to make it fixed length, and we will do this for every sentence in the list of questions and answers, and we will have fixed length of questions and answers. And out means if that word is not in our vocabulary, then we will append the out token to that. So let us run it and append these tokens to our vocabulary. Alright, so now we have appended words or tokens to our vocabulary. Now we have to do one last thing. Our padding usually signified by 0 in the integer form when we pass it to decoder. So we have to assign padding a 0 value, and on our index 0 or value 0 there is a word called Cameron. So we have to say that Cameron value will be replaced by pad value and pad will be 0. Now we have to inverse this dictionary. Let's do it quickly. That is again quite easy to do. Let us first get rid of unused variables. Alright, so it is quite easy to create inverse dictionary. We will be saying W as key and V as value for VW in vocab.items, just reversing everything. Now we have our inverse dictionary or inverse vocabulary and our vocabulary. And alright, so till now we have created our vocabulary and inverse vocabulary and our list of questions and list of answers. Now if you don't know how to do these all, make sure you watch the previous 2 parts and then you are ready to follow this part 3. Alright, so now we have to convert this list of questions and list of answers to integer values. Now why integer values? Actually the neural network or machine learning algorithms can't handle the string data. So we have to convert them to numerical values, either float values or either integer values. So how do we do that? So we will be using this vocabulary and we will be checking that if that word is available in this vocabulary, then assign that particular value, assign that particular value of that particular key. Now if it is not available in this vocabulary, then we will assign the out keyword. Again, if you don't know how to create this inverse vocabulary and this list of clean question and answer, make sure you watch the previous 2 parts. Alright, so without wasting time, I'll be copying the code and pasting it right here so that it won't take too long to write the code. Now here is our encoder input. What is encoder input? This is something which we're gonna pass to the our encoder, and then we will be creating decoder input, which will be something which will be the output, which will be used to calculate the output. So encoder input will be the question, decoder input will be the answers. So what we are doing, we are saying for line in clean questions. So these are our clean questions. So what we are saying, we will be iterating in the list of clean questions, and then in that we will split that particular element or particular value of that list, and then we will iterate through each and every word, and it is written right here. So we are saying if line for line in clean questions, then we have created a list. We will see what this list is doing. Then we are iterating in that list, in that particular list, by using word.split. Then we are checking if the word is in vocabulary. I have already explained why we are checking if the word is in vocabulary. Now vocabulary is the dictionary of all the words contained in questions and contained in answers. So why we are checking if that word is available in that? So remember in the previous part we have applied a threshold, means minimum amount of time that word has occurred in the list of question and answers. So if the word has value less than 4, then it will not be considered in the vocabulary, and in place of that we have applied out keyword. So for that purpose we are checking if that word is available in vocabulary. We will So if that word is not in vocabulary, we will append out keyword. If that word is available, then we will append the value corresponding to that word as a key. Then fine. Okay, so we are appending that to a list. So finally we will append this to the main encoder input list. Again, we are iterating in this list one by one. Then we are iterating in this list, and we are appending to this lst converted integer values, then appending whole list to this encoder input. Let's see how does it looks like by running it up. Alright, so we have our encoder input, and here you can see, let me maximize this a little bit. As you can see that now this is converted to the integer values, and that is something which is required by our neural network model. Now we will do same thing for questions also, which will be our decoder input. That is ditto copy of that, just we have changed clean answers, and new will be decoder input list. Let's run this up, and we have our decoder input, and it would be similar to that. Alright, now we have our finally encoder and decoder input, which are ready to transfer to our neural network. But wait a minute. Let me show you. Okay, so as you could see that over here its length is 1, over here is 2, and here is 3, then again 2. Now it's not ideal for transferring to our neural network. So what we have to do, we have to pad the encoder input and decoder input with maximum length of 13. You could choose any length you want. So we are importing pad sequences from keras.preprocessing.sequence, and we are using pad sequence, and in that we will transfer the encoder input, and this is the max length which we want. Then we did padding, and then truncating equals to post. So let me explain you what does that all mean. Let's consider this one. So what we are saying that truncate first 13 elements. If there are less than 13, apply 0 in the post, in the after of that. So that means all that padding equals to post, it will add 0, and truncating equals to post means we split the list from first 13 elements. So let's run this, and now we would have our it will take some time to run. Alright, so finally we have our fixed length all of 13. Let me show you all of length of 13 starting from 0 to 12, and we have fixed length, and 0 means padding. And if you could see in our vocabulary, and the 0 will be pointed to padding value. Alright, so now we have to do one more step, and that is final step, I promise you. Now what do we want? Basically we have our encoder, which we transfer our question, and it outputs the context of that question, and it is transmitted to our decoder as input with this decoder input. And this outputs one timestamp further to this decoder input. Let me show you what does that mean. So this is our start of string token. Now what we will be doing, we have passed our question to our encoder as input, and it transmitted context of that particular question. Now what decoder model will do, it will expect this first timestamp, it will input this plus the context came from encoder input, and it will predict next word. So we have to remove this first column and transmit this whole thing to this 0 index. So let's run this and let's see what does that mean. So here are our decoder final output, and this is one timestamp further than our decoder input.
and at the last we have appended 0 as padding. Now we have our final data variables which are ready to transfer to our model.
And in this video we are going to see how to build encoder decoder model. But before, let's quickly see how this model looks like and how it works. Alright, so let's start from the user end. First of all, user gives the input and then it is fed into the embedding layer. We would later see what this embedding layer do. Then this is sent to the LSTM network, and LSTM creates the context from that vector, and that context is known as states or internal states of that model. Then those states are sent to the decoder model with the SOS or any particular token, and then it predicts the next word, and that next word is transferred to the decoder, and then again it predicts the next word, and this cycle continues and this goes on. And now let's quickly see what we have done in our previous three parts. And in the previous three parts we have done all the data pre-processing we need, and now we have the data which is ready to be transferred to our model. If you don't know, please go ahead and watch those three parts because those are super necessary for this part. First of all, let us quickly make some normal imports like dense layer and LSM layer. These are obvious, we need to import them. And embedding layer, I will explain you later when we'll use this embedding layer. And one thing you might notice is that I'm importing model instead of sequential. This is because model is a functional approach, and this gives us more control in our hands to optimize the layers or to use the layers wherever we want, like we will need them during the inference. And so we are going to use functional approach instead of sequential approach. One thing I forgot to do in pre-processing part is adding this toCategorical function to this decoder final output variable. What this do is it converts the 2D data to 3D, which is expected for LSTM output. It creates a separate column for every word in the vocabulary to the decoder final output variable. It creates a 3D matrix of so many zeros and so many ones. You can run this and see this. Alright, so once you have made all the necessary imports, let's create an input placeholder for encoder and decoder. And we would simply do by using saying input and giving it shape as a tuple, and in that we will pass 13 comma none, and 13 means the length of input which we are going to pass in. So we will do this same for decoder. It basically holds the value which we are going to pass during the runtime or during the training time. Alright, so now let's quickly create an embedding layer. Embedding layer generally reduces the dimensionality. We pass in input dimension, which is the length of the vocabulary, and we need to give it a output dimension which we want to reduce. So for example, in our case vocabulary size would be 3000, so it will going to compress that into just 50 values, 3000 values to 50 values, so it reduces the dimensionality. And we just give it three parameters. One is input dimension, output dimension, and input length. This is the length which we are going to give it during the runtime, and that is it. Now let me give you a quick example. Okay, so as in our case, the input shape would be a 20, 13, which is 20 is the number of the samples which we are going to pass in length of question and answers, and 13 is the length of one question or one answer. So once we pass this to embedding layer, this would give us 20, 13, 50, the output dimension which we have set later when we were defining embedding layer. So quickly, why do we need to convert our 2D data to 3D? This is because LSTM expects the 3D data. So this is it for embedding. If you want further reading, I will link down this resource. And now it's time to connect our encoder decoder placeholders with the embedding layer. It is as simple as just passing in them these braces. We will just say embedding and that braces and encoder input, and we would later on do the same for decoder input. And now let's quickly create our encoder LSTM layer by simply saying LSTM, and we'll name this as ENC LSTM. And the first parameter is the number of cells, LSTM cell. We will pass 400 for now, and it takes return state equals to true and return sequence equals to true. Return sequence generally returns the hidden state at every time step, and return state returns the hidden state and the cell state at the last time step. If you want further reading, go in the description, and I would link best reading which I found for this explanation. So now we will connect this LSTM layer with the encoder embedding in order to access the encoder output H and C. We are able to access H and C due to return state equals to true, return sequence equals to true. So you need to set them to true if you want them. And now at last we will just create list of H and C by just saying passing them to a list. And now let's add decoder LSTM. it is just similar to encoder lstm cell, but the thing is different is that we will use encoder state as its initial state of decoder lstm, as you can see in the diagram. And one more thing we have to change is going above in the vocabulary size, we have to add 1 instead of reducing 1. This is because we are adding pad token extra in our vocabulary, so we have to tell it by specifying +1 in the vocabulary. And now let's create a dense layer by just simply saying dense and name this as the small d dense, and it will going to output the probabilities equals to the vocabulary size. And obviously we need probability, so we will use the softmax activation function. Now we have dense layer, now we will connect this dense layer with the decoder output in order to get the final dense output. And now it's time to finally wrap everything up. We'll use model class in order to create model, and we have already imported. So now it takes 2 arguments or 2 values, which is input data and the output data. Input data is obviously encoder input and the decoder input, and the output data is the final dense output. So let's quickly replace them up. And now at last we will compile our model by saying model.compile and setting the Adam optimizer and categorical cross entropy as a loss. And now at last we will fit our model on our preprocessed data. And if you don't know how to preprocess data, go ahead and watch previous 3 parts, and we know we had encoder input, decoder input and decoder final output as our preprocessed data. So now let's quickly replace them up, and we will use 40 epochs for now. Now to run this code, I will jump to Kaggle because my laptop is not too powerful. I will copy the code which we have just coded and that previous 3-part code, pre-processing code over here. As I've told you that vocabulary size, so we will use length of vocabulary, and that is it. Let's quickly run them up, and for now I will just use 2 epochs just to show you that it works. And at last, to use this model we would have to create inference, and this is something we are going to do in the next part. Now we are going to build inference model in this part to talk to our chatbot. So once again we are going to build a different encoder and decoder model from our previous encoder decoder model to create our inference setup in such a way if we pass in text and it gives us out the predicted next word. So we are going to use previous model to create this inference model. So let's jump into the video. In the top we have encoder model. Let's just first focus on this encoder. This is going to be really simple. Just we are going to pass in the text and it will going to give us its internal states H and C. It is really easy to build, so let's just build this model. And this is the model which we have already built in the previous part. If you haven't watched, go ahead and watch this part. So let's start this video by making some simple imports. One is model and another is input import. Now let's build the encoder model, and it is really simple. We will name this as encoder model and we will use model class, and as an input it will have text and it outputs its internal states. And we are going to use encoder input from the previous model which we have already built and encoder states from the previous model which we have already built. Now as you can see on the screen, we have encoder model which is already been created and has been trained on the network, and we have encoder states similarly in our model. And now let's build decoder model, and it's a bit complex to make, but I will try to make the things simple. So over here on the screen you have model, and as you can see we used 400 cells of lstm, so this is going to return a 400 vector of h and 400 vector of c. So we have to build an input placeholder for h and for c, both of them. So we will just name them decoder state input h and decoder state input c, and we will specify input shape equals to 400 none, and we will do same for decoder h and decoder c. And now make list of this both h and c by giving it name decoder state inputs, and create list of h and c. And now as I said that encoder state will be input to our decoder model, so it should resemble the structure of this encoder state. So it has the similarity between encoder state and decoder state inputs. Why we didn't use encoder state? Just to avoid graph disconnects, so we have used different placeholder, but they both have same structure. We will use them later when we will be predicting some things. And now finally let's build our decoder model. So as you know, in previous part we have built decoder LSTM, and you can also see on the screen we have decoder LSTM from the previous trained network. So what we are doing, connecting this decoder LSTM with decoder embedding layer, this is also previously built, and we are setting initial states to be decoder states input. Both of them, decoder states input and encoder states, have similarity between them, and we are going to use during the prediction, not now. Now this is going to return us decoder output, state H and state C. State H and state C are the internal states of decoder LSTM. Now we are going to create list of state H and state C, and we will finally build the model. And this is our model, and it has input of decoder input. We have already this layer trained previously, which is decoder input of shape 13 comma none, and it has input of decoder state input. I've already told that this is encoder state equivalent. And we have a decoder output, which is the prediction from the decoder lstm, and the decoder states, which is state h and state c list. Okay, so now before moving further, make sure everything in your mind. If you not, try asking them down in comment section or try rewatching the video. And now it's the simplest part, because we are going to say just encoder model.predict, decoder model.predict, and just appending and removal and just if else statements. Now make sure everything makes sense. Now let's jump into the next part. So we are saying prepro1, it's a variable for the user input, and if the user presses q in the keyboard or as the input to prepro1, it is going to take us out of this loop. And now we are applying clean text function to our prepro1, which we have already built in the preprocessing part. So now let's start explaining by taking an example so that it makes more sense. Let's think that user inputs capital HELLO, hello input to the chatbot, and then clean text function will going to transform it to small HELLO and apply all the transformations which we defined in the clean text function. And now we are converting this to list. So now prepro will be something like list of HELLO. And now hold your breath, because something awesome is coming. This time we are using another list of txt, and we are iterating in the prepro, and because prepro is a list, so we can iterate in it. Now we are creating another list lst, and we are splitting that hello word, and if there would be some spaces, we're going to split them in the spaces. So x would be looking like HELLO, and similarly y will be HELLO, and then we are trying to append the vocabulary of y. Vocabulary is a dictionary of all the words which we have trained on our model or chatbot. So let's say if vocabulary of hello as a key has the value of 454, so if we're going to append 454 to the lst, and that lst is appended to txt, so now finally txt should be looking like list of 454. All right, so much in it. Try using longer sentence and think of it, and try and run on this, and make sure this is fully understandable to you. Now we are applying paired sequence to our txt. So now this time it will be converted to numpy array of length 13, and it should be looking like 454,0,0 up to the 13 length. And now we will be using encoder model.predict to predict the txt, and we already know that it will going to output us its internal state. So we can say encoder model.predict. As you can see on the diagram, it has input of text and output of h. And now we are creating empty target sequence of zeros, so it should be looking like a numpy array of 1 column, 1 row, and everything values of 0. And now, as I said, we will be sending SOS token to decoder model, so we'll convert SOS token to integer value and set it to empty target sequence 00 index. And now we have two more variables, stop condition and decoder translation. As we are going to use true loop, so we are going to set stop condition equals to true once we hit the max length or EOS token, and decoder translation is the variable which is used to hold the predicted output of our chat. Now finally we are going to use decoder model.predict, and we will transfer this SOS token which we have already converted to integer, and encoder states which we have already got from encoder model.predict. And now at last we will send this decoder output to the dense layer, and dense layer which we have already defined in our model. And let me show you it to you once again, the dense layer, and it will going to output probabilities up to the size of vocabulary size which we have already defined in our previous parts and decoded. So we are using softmax function, so it will going to assign the probabilities to each and every word in the vocabulary. So think of it, it's something looks like this 0.1, 0.2 means the probability assigned to every word in the vocabulary. And now we will use np.argmax function to take out the maximum probability index. So in this case it should be 0, 1, 2. So in this case it should be sampled word index should be 2. Now we will use inverse vocabulary to take back our word. So sampled word should something look like this. Now let's take an example once. So let's assume on the inverse vocabulary of index 2 there should be a value high. So it is going to assign sampled word equals to high and 1 space just to decoration. And now at last we will check if sampled word is not equals to end of sentence, we will going to assign it to decoded translation, or if that sampled word is equals to end of sentence or the maximum length of decoded translation is greater than 13, we will going to get out of this true loop. And now this is the most important part, resetting the variables. Now we have to reset empty target sequence to the new predicted word, and that state stat to the new internal states of decoder, as you can see in this video. Once again, let's understand by example. So we have first empty target sequence was SOS and it predicted as high. Now we will set empty target sequence as high and it is going to predict some new word, let's say EOS. So the while loop will going to end and we have the output of high. Now at last, once we get out of this true loop, we only have to show to the user what the decoded translation is, and that is the final inference setup. Now let's just go into the Kaggle and try running this code. I'll train for let's say 10 epochs and I'll fast forward this just to save your time. And it is trained for 10 epochs, and let's just try our inference setup to make some predictions. There we go. Let's just try asking hi, how are you, and simple question answering. And let's see how does it makes the prediction. For now it's only trained for 10 epochs, so the output should not be super interesting, super cool, but if you train it for more epochs it should generate better outputs. And I guess that I should end this video at this point of time. And if you think I'm able to give you something new today, so make sure you thank me by subscribing my channel and giving this video a thumb up. And if you have any queries, make sure you ask them in down comment section. I'll going to shortly reply to your comment. And in the further videos, we are going to add attention mechanism and bidirectional LSTM to this model, to our chatbot. And I'll see you in the